Afternoon. I received this project from you, and I want to do the first few piles with you, and then you will do the rest yourself. So, without due delay, let's start with the very first one. Okay, so that's pile number one here. And the first thing that I do before even analyze is I look at the selection of the impacts, and I'm selecting a few ones which are irregular just by clicking on them. I just click on any area here. So I click, it's getting selected, and then I press the delete button. Okay, so now I have a better set of impacts. When I delete an impact, the average changes, and as a result, the length mark jumped to the right location, just at the minimum point of the signal. So we can see that this difference between 5.6 and 5.8 meters from the expected length is really neglectable. It's basically the same length. Next thing I want to look at is I want to make this amplitude and this amplitude the same. For this, I need to amplify the signal more so that this area will be more amplified. One way to do that is to play with the amplification bar here and change it. You can also just hover over it and see what's the effect, and then click on the right amount. Or you can use the magic wand icon here. Just so no matter what's your amplification, just click on it, and it's going to set these levels exactly the same. So this file looks perfectly good. I want to add. Usually, I like to see a little bit more scale here. So I just double click any of the scale numbers. Gives me a little bit extra room here. It's just more of a aesthetic preference. So since all your piles are about this length, I'm going to use this as a default scale. I'm going to save this pile. Now I'm going here to the pile menu, modify all, and I'm going to set the length scale to all piles to 11 meters. So it's going to be uniform in the project. Okay, and pile number two. Pile number two, again, we have some irregular impacts, but it's not that bad, so I'm not going to delete them. You can see that the length mark is not on the right location. So what I can do, this is the length mark, and a simple double click on that, or a right click, and it's going to jump to the minimum point of the average. So it's just snapped to the right location. Next thing I want to do is match these levels using the magic wand. Got it. I've got the scale. Everything looks good here. And I can move to the next pile using this icon here. Okay, again, a few noisy impacts, but not that bad. Magic wand. Looks good. Next. Okay, magic wand. It's not working well. Why? Because the length mark was not on the right place. So right click on the length mark, magic wand. Okay, looks better now, but I can see that some of the impacts are really noisy. You should really improve your hammering technique. Now, another way to watch and get a very good assurance that this is indeed the end is by doubling the length. So I just dragged the scale here to get more scale. Now I'm going to drag the end of line here. And I can clearly see that I have a first reflection here and a second reflection here. So this is a very good verification, especially if I increase the amplification. I can see that I have a reflection and a second reflection. So I'm quite sure that this is indeed the end of the pile. Okay, to get back to my changes, of course, I can undo them one by one, but I can also click here the undo button and just go back on amplification, back on the end line, back on scale, and I got what I did 3 steps ago. Next pile, pile number 5. Pile number 5 is a bit more interesting. First of all, let's click the end of the length mark to the location. Got it. Let's do automatic uh, amplification. And now I decrease a little bit the end of line mark here, but don't want to see so much. Now, and I can click it again. Okay, so now we have that, and that we know. That's the hammer impact. That's the end of that's the toe of the pile. But what's that thing here? So intuitively, when something goes up and then goes down like that, that's a local bulge. And to verify that this is indeed a local bulge, what we can do is we can add some filtering to make it a little bit smoother. And we can now go to the signal matching, which is usually used as a more advanced analysis tool, but let's give it a try now. So signal matching. First thing I'm going to do is set the solid profile friction so that this area here will match the impact. Okay, got it. Okay, what we see here, the blue line is the data that you measured. The orange line is a simulated data based on this pile shape. We can change the pile shape just like that. And it already gives us quite a good idea that we are not that far from reality. Maybe it's a bit exaggerated. We can also ask the software to do it for us automatically using that button. And although this is a more advanced analysis technique, let's give it a try now. So I'm pressing that. It's running some mutation on my selection. And as you can see, the orange line gets really close to the blue line now. We get a very nice match. We can stop it now. And we can see that we have a local increase. Okay, stop. We can see that we have a local increase in diameter here. Okay, we can ignore this pen-shaped thing. It's quite typical. We're going to use the save button and then exit. So saving and exit. And in my comments, I'm going to write local local cross section increase. Oops, sorry about that. At, and I'm going to use the mouse to click on the right location instead of typing the length. So I typed it. Fine. Okay, no big deal. I'm going to move to the next pile. Okay, pile number 6. We can see some noisy data here. Let's delete it. Rest of the pile looks quite uniform. Length mark was moved now to the right location and increased the scale a little bit. This difference here is really no big deal. So that's a good pile. Let's just press the magic wand once again and move next. Okay, this is a bit more challenging pile. Length mark is on spot. Magic wand shows us this. And what we can see is that we have probably at least one local increase here. And this might be a second one or a second reflection from the same local increase. It's quite hard to tell. And usually it's too presumptuous to find two issues below the length. So let's just say a non-uniform profile. Okay, without specifying any more. The pile is a bit longer than planned, um, 6.5, so a meter and some longer than planned, but that's what we get. It's quite clear that this is the end. Again, we can do the same trick here, trying to look at second reflection, but because this pile is quite noisy, which this should be at 15 or something, it's quite hard to tell if this is indeed a second reflection. Undo, undo, and next pile. Pile number 8, analyze it the same way as you analyzed pile number 7. Let's put the length mark here. Magic wand. We probably have at least one increase, if not two here. Next, you will need to add the comments here. Pile number 9. I'm using the magic wand, and same story. It looks almost identical to the previous ones. Okay. Pile number 10. Same thing. Magic wand. Okay. I want to understand what's the soil profile in this site. I think it's in some areas it's really rough. I mean, we can still see a very clear toe reflection, but this is an indication of a very non-uniform profile in these piles. So after you analyze the rest of the piles, or before that, investigate what's the soil profile, what's the drilling method, and why are we getting such a non-uniform profile in so many piles? As you can see in 10, 9, and then in some piles it's really nice, but 7, 8, 7, 8, 9, 10 are rough. Then again, we go back to 11, which is much shallower. Looks good. Second reflection here, nothing much to see. Good pile. We can delete this irregular impact if we want. Looking good. Same thing with pile number 12. So I really want to understand what's the issue here with this non-uniformity. I'm looking for more piles that are interesting here. Okay. Okay, that's definitely not the end of the pile here. This can be that or that, but that does not look like a really good pile. If you will look at this at a higher frequency, we can see that it's quite a noisy pile here. I need to understand what's the story with this pile. Okay, there's always a background story, which I want to understand. Close without saving. I'm just scrolling through the piles, trying to find out something more interesting. Okay. What we can see in this pile number 83 is that we have a very repetitive noise here, really repeats. We can verify that using two methods. The most intuitive one is this icon here, the repetition marks. And the repetition marks is something that you can put and stretch together. And then you can see that it really repeats at a very uniform interval. It always matches the low of the pile. So we have a very uniform repetition period, which is, if you move the mouse over the first one, which is at 0.8 meters. Okay, and we can still see the end of the pile here. So two things we need to do. First of all, we're going to apply a lot of filtering and sharpening. So a lot of filtering, even number 10, a lot of sharpening. Now this pile looks a little bit better, a little bit clearer. Magic wand, double click on the length, forget the repetition marks. Okay, this now looks quite good. But in our comments, we're gonna write that we have a reflector at 0.8 meters. Okay, so that was 83. Let's and looked at. Oh, yeah. I'm looking for more things like that. Okay, so number 93 shows a very similar thing. Just apply a little bit more filtering, a little bit more sharpening, and use the same comment about the reflector. So the reflector here is about same thing, 0.8 meters. Okay, I think I analyzed all classes of files here. So what you need to do is analyze all of the files the same way I did, uh, apply the same parameters, and put the length mark on the right location. For example, here you can see that it's wrong. Here, almost everywhere here. So put the length mark right, apply some filtering, some sharpening, set the amplification and scale correctly, and then you're quite good to go. Send me everything and I will review it. Thank you.